Hi, algebra students. We are going to be starting a new unit today. We're going to be working on polynomials. So let me share the screen and start the presentation. First thing we have coming up is a warm-up, and it's actually in your journal on page 204. I'd like you to complete explorations 1, 2, and 3 on pages 204 and 205 in your journal. So go ahead and pause the video, try those, and we'll come back together. Okay, welcome back. So it's showing you how to work with algebra tiles to combine some polynomial expressions there. And if you look, they walk you through the steps, and you're supposed to figure out how to combine those terms in there. Let's go ahead and jump to the third question here. How can you add or subtract polynomials? Hope you were able to figure out that to add or subtract polynomials, you can, and I'll grab my pen here. Maybe. Number 3, to add and subtract polynomials, we combine what we call like terms. And we say like terms because they have to have the same variable, and the variable has to be raised to the same exponent, has to have the same power. All right, so we're going to look at number 4. So this is also still in the exploration, page 205. And number 4 says to find each sum or difference. So we're going to talk about, and you can think about the algebra tiles again. You have an x squared tile, that's a squared here. You have 2 of those over here for a total of 3 of those x squared tiles. Those are the bigger ones. Those are the squares, all right? Then we have the x tiles, and those are the ones that in the picture looks like they just have a big plus on them. So we have a 2x here plus a negative 2x. Well, 2x plus negative 2x is 0, so I don't even need to write that one down. And then I have a negative 1 plus 1, which is also 0. Excuse me. So A, we should just have 3x squared. All right, let's look at B. Here we have a 4x. So 4 of those plus pieces, and 1 of them over here for a total of 5x. And then we have the little tiles, and let's see, we have 3, and then 2 negative ones. Remember, 2 of the negatives will cancel with 2 of the positives, and so we just have 1 left over, positive 1. Or you can think of it as just 3 minus 2 is 1. All right, let's jump to C. This time it's subtraction. So I have to remember that I have these terms here that stay as they are, but this negative, if you want to think about distributing, is going to change the sign of everything in this parentheses. Or I can just go step by step. What's 1x squared minus 3x squared? 1 minus 3 is negative 2x squared. All right, and then I have this 2 minus, well, I got to look at what I can combine it with. It's not this 2x, right? That's not with it. But I'd have 2 minus, I have a 5 over here. 2 minus 5 is negative 3. So I've taken care of this, and this, and this, and this, and I'm left with this 2x that I need to do something with. So this is like 0 minus 2x, which would be a negative 2x. Now, you usually won't see polynomials, if these are called written in this order. They'll usually go by, well, what's your highest degree? And they'll put the 2x squared first. All right, what's the next highest x term? Oh, 2x, so that'll come next. And then the constant term, the 3, will be the last thing that you write down. All right, let's go over here to the next one. Oh, this one I'm seeing, oh, I have some like terms here right in this parentheses that I'm going to combine first. So I have 2x minus 3x is a negative x. And then I still have my negative. And I'm showing you another way to do this, and we didn't do it in the last one. But I could go ahead and distribute and get rid of the parentheses over here on the right. So I've gotten rid of my parentheses here because 2x minus 3x is negative x, but I'm going to do the same thing in this side. So when I take this negative, that's like a negative 1 here, negative 1 times x squared is negative x squared. Negative 1 times a negative 2x, and negative times negative is a positive 2x. And negative 1 times a positive 4 would be a negative 4. All right, so now I can combine some like terms. I can put them in order from highest degree to lowest. So I'm going to put my negative x squared first. Next, I have negative x plus 2x. Those are like terms, right? Those are the pieces with just a plus sign on them. So I have -1 plus 2 leaves me with a +1. And then I have -4. All right, let's go ahead and jump into the actual lesson here. You have some vocabulary. So it says here a monomial is an expression that is either, I'll move my screen here so I can see. It is a number, a variable, or a product of a number and one or more variables. So here's some examples of some monomials. So mono is 1, -4 is a monomial, 3xy is a monomial, 5y squared, 6a cubed b squared, and x divided by 4. These are all monomials. The reason why they're monomials, we don't have any like plus or minus in between these things like we did in all those last examples that we had in the exploration problems. All right, so another thing that you need to write down in your notes is the definition of the degree of a monomial. And this is on page 206, this vocabulary. So go ahead and copy that down. Oh. All right, so a degree is the sum of the exponents, the variables. For a non-zero constant, like just a number, the degree is 0. So we're on page 207. We're looking at some extra practice. We're going to look at, looks like 1 through 8. So let's go ahead and take a look at that. Find the degree of each monomial. So let me grab my pen again. I'm going to switch up the color just for fun. All right. So on number 1, what's the degree? Well, I only have one variable here. This has an exponent of 1, even though it's not shown. That's -6x to the first. So this one has a degree of 1. Same thing here, w to the first power, degree is 1. There's no variables here, right? And it says up here for a non-zero constant, the degree is 0. All right, this time I have several variables. And what does it say I do for the degree? The sum of the exponents. So this is a to the first, b to the first, and c to the first. So the degree of this monomial is 3. 1 plus 1 plus 1 is 3. Number 5, I've got a couple different variables. This one has a 2 as an exponent. The y has a 1. So the degree of this monomial is 3. 2 plus 1 is 3. Number 6, we have 2 plus 3 is 5. Oh, and there's an invisible 1 here. So 2 plus 3 is 5 plus 1 more is degree 6. All right, on number 7, this is m to the first and n to the third. So our degree is 4. 1 plus 3 is 4. Lastly, this is 2/3. And if it bugs you to look at it that way, you can write it as 2/3. That's a constant and the degree is 0. All right, we have more vocabulary terms, so please pause the video and write down these definitions on page 206 in your journal. All right, welcome back. Let's move on to our next slide here. Hopefully you got all that vocabulary because we're going to be using it now to do these problems. All right, we're going to jump to extra practice problem number 9. It says write each polynomial in standard form, identify the degree and the leading coefficient, then classify by the number of terms. All right, so this is number 9. I'm going to grab my pen. So the first thing we have to do is write it in standard form. So standard form is highest degree first. So this is x to the first, 3x squared. Oh, that's higher. I'm going to put 3x squared first. Then my x term comes next, followed by the constant. All right, that's the first thing they asked us to do. All right, next it says, identify the degree and leading coefficient. So the degree of this is 2. When you have a string like this, when you have several terms, the degree is the highest degree. So this is degree 2. The leading coefficient is this number sitting right in front of the x squared here. So you go to your highest degree term, the number at the front is your leading coefficient. So in this case, our leading coefficient is 3. And I'm going to abbreviate coefficient here. And then it says classify by the number of terms. Well, let's see, this says 1 term, 2 term, 3 terms. Remember, terms are separated by pluses or minus. Since this is 3 terms, it is known as a trinomial. So one term is a monomial, two terms is a binomial, three terms is a trinomial, and if it has any more than three terms, we just call them polynomials. All right, we're jumping to number 11. All right, is it in standard form? Nope, I look at my degree, 8 is bigger than 5. So I'm going to write it as 6x to the 8th plus 3x to the 5th. Now it's in standard form. This time the degree is 8. That's the highest degree I have there. And my leading coefficient, this time I'm just going to abbreviate it as LC. My leading coefficient is 6. That's this number here. And this time we just have two terms. So this is an example of a binomial. All right, let's look at our next slide. It says you can add or subtract polynomials by combining like terms. Complete extra practice problems 13, 16, 18, and 19 on page 208. All right, so let's take a look at number 13. We have, I'll grab my pen. Okay, number 13. And maybe you guys want to pause the video and try these and then come back and check. So number 13, we have negative 4x plus 9. And we have plus 6x minus 14. All right, so I'm going to combine like terms. I have negative 4x plus 6x is 2x, and 9 plus a negative 14 is negative 5. All right, let's look at number 16. Okay, hopefully you tried this one already. So I'm going to go ahead and jump to the answer. So I'm looking at number 16. I have a t squared plus a 2t squared is a 3t squared. All right, next I jump to my squared terms. I have t squared plus 2t squared. Oh, I already did that. I didn't see my cubed here. Let's back up the algebra train here. Maybe I should take the time to write it down so we don't miss it. So I'm going to do that. T squared plus 3t cubed. I missed my cubed. And then minus 3 plus, in the second parentheses, I have 2t squared plus 7t minus 2t cubed. And that's a 7. That doesn't look like a 7. All right. So let's try that again. So t cubed, I have 3t cubed minus 2t cubed is 1t cubed. I have a t squared over here and a 2t squared over here for a total of 3t squared. I have a negative 3 here, nothing to combine it with. I have a 7t here, nothing to combine it with. But I'm going to put it in standard form. So I'm going to put that 7t term first and then the negative 3. All right, let's look at number 18. This time we're doing some subtraction. It's asking us to find the difference. So be careful with your negative signs. I have negative 5h minus 2 minus a 7h plus 6. All right, if it helps you, you can always rewrite these without the parentheses. So my first expression is 5h minus 2. I have to remember that this negative gets carried throughout this binomial, so negative 7h. And then we have a negative times a positive would be a negative 6. Now I'll combine my like terms. Negative 5h and negative 7h is negative 12h. And negative 2 plus negative 6 is negative 8. All right, one more here. Let's look at 19. This time we have in the first parentheses a negative x squared minus 5 minus, let's look at the second parentheses, a negative 3x squared minus x minus 8. All right, this time let's look if we can figure out what these changes would be without actually distributing and rewriting. So let's look. We have a negative x squared here. I'm going to switch pen colors here for a second. If we look here, we're going to have a negative 3x squared. So negative x squared, that's going to turn into a plus 3x squared would be 2x squared. All right, I've got my minus 5 here and a negative, and again, a negative, -8. That's going to make that a positive 8, but I'm going to put it at the end because it's my constant term, and I have something else in here. Notice this only has 2 terms, but over here we have 3. So I have this negative x inside. This negative here is going to make it positive x. All right, so now I've written it in standard form, highest degree first, and I've combined all my like terms. All right, this is your assignment today. For those of you in class, we're going to walk through number 6 to 18 even together, and then I'll turn you loose for 23 to 35. The assignment is in Schoology. You'll find the link to the textbook pages there. As always, if you have any questions, just send me an email. So good luck.